Hi, Assalamualaikum and a very good evening. My name is Amal Muaz bin Muhammad Nasir. Currently, I'm a fourth year student from Engineering Faculty of Electronic and Computer. So today I would like to give a brief explanation about my final year project. The title of my final year project is to develop and analyze saturable absorber film from plant leaf for Q-switch fiber laser generations. Without further ado, let's move on. So what is actually Q-switch fiber lasers? To make it simple, lasers is in terms of power. So usually power is in a continuous wave. So if it's in the in a bit form, it always to be one. Okay. So in order to make the pulse in a continuous form to be on and off, we have to put a Q switch. Whereas the Q switch will act as the switching to make the continuous wave to be on and off in a short period of time, in a very short period of time. So in order to do that, this research has been conducted. Okay, so this is the component of this research. Okay, we must have this fiber laser cavity in order to generate the pulse lasers. The first component is the pump LD, which is the laser diode. This is where the pump the laser diode is the power comes from. So it will go to the WDM. The function of WDM component is to propagate the signal or the power signal to be entered to the erbium dot fiber. So the erbium dot fiber is act as the gain medium. So the output power can be generated in the mid-infrared wavelength, which is in 1.55 micron M wavelength. So after that, the signal will go through the isolator. The function of the isolator is to prevent the backscattering of the signal. So to take care the pump LD, because pump LD is a sensitive machine. Whenever there are a backscattering signal, it will the machine will be broken. After that, it will enter to this one box. So this is actually represent as the optic fiber ferrule. At this optic fiber ferrule, it can be dismantled. So the Q switch or the SA saturable absorber film can be put in between the cavity. This is where the film will be analyzed. Okay, and then it will goes to the 9 to 10 coupler. This is whereas the 90% of the power will be entering back to the cavity, and 10% of the power will be sent to the optical spectrum analyzer and oscilloscope to be analyzed. And this is isolator that I have explained just now. So that is what Q switch. So to make it simple, the population inversion region is where the pump diode, the signal power comes into the optic fiber ferrule. Okay, whenever it hit the Q switch film, the passive Q switch film, in this case is the saturable absorber film. I will call it as SA after this. It will be in a saturation level. A saturation level, whenever the saturation the level the stored energy is enough, it will emit the power in one rapid pulse. So this will be continuously on and off in a short period of time in terms of microseconds. So background studies of this research is the Q switching techniques are effective methods to achieve short pulse microseconds, and the energy rating can reach millijoule or 100 of nanojoule level. So different from active Q switch, passive Q switch is low cost, high flexibility and compact, and also favored various application. So with cooperating with the erbium dot fiber laser as a gain medium, so this research will give interest and generate microsecond pulse Q switching operation in mid-infrared waveband. Okay. Now move on to the objective of my research. So I have three objectives. This research have been conducted. The first one is to analyze the pulses range of plant leaf passive Q switch for stable laser pulse in the mid-infrared waveband (RO1). For the RO2 is to develop a saturable absorber from plant leaf In my research, I choose eggplant leaf. I will tell you why after this, for varying passive Q switching fiber laser generations. And lastly is I want to study the saturable absorber material for passive Q switch and to diagnose the EDFL, the gain medium, to utilize the system at its optimum performance. Okay. The significance of this project is parallel to the United Nations SDGs number 9, which is to build resilient infrastructure to promote inclusive and sustainable industrialization and to foster innovation. This is because the process of manufacturing design of the passive Q switch in the lab have used minimal or no adverse environmental impact. So by recycling and reuse of the feedstock or the leaves for subsequent deposition is a very recommended to improve the sustainability of the optic fiber research and the development. Now let's move on to the research methodology. The first one, obviously, we have to start the research. So we need to research on project literature review or the erbium doped fiber lasers. And then I have to identify the existing set SA in the market or that have been uh, the research that have been conducted by previous scholar. And next, I have to master the splicing technique for the optic fiber laser system or the cavity. And then the next step is to fabricate the organic SA, which is the SA from the plant leaf using proprietary method. So after I get the film, I will analyze the film using optical spectrum analyzer and oscilloscope. So when I get the desired output, then the research is done. So now move on to the fabrication and synthesizing process of the plant leaf SA. The first one I need to plucking the leaf. Of course, I plug the leaf. So why I choose the eggplant leaf? I choose eggplant leaf because it contains more chlorophyll compared to other leaf. Okay, based on my references. So to obtain a Q switch that can derive carbon in so I need to choose a leaf that is contain more chlorophyll in it. After that, I have to keep the leaf into the oven for 300 degrees Celsius for 3 days. The third step is I have to crush it into fine powder. So as you can see, this is a conventional way to crush the base material. So in my case, I use what we call I use electrical grinder to crush it into fine powder, and then it goes to filtering work, and then it goes to the mixing process. Whereas the base material is the fine powder is mixed with isopropyl alcohol and stir with using the magnetic stirrer, and then it goes to the centrifuge process, and lastly it goes to filtering work. Let's move on to the result and output that have been obtained from the SA film. So this is SA film after all the process of the fabrication have been conducted. This is the eggplant film. So to put this film into the fiber optic cavity, I just need only a small chunk of this film to be put in between the end of the ferrule, and then connect it back into the cavity. So this is the data output, the example of data output that have been obtained. This is the first data output, and this is the 10th data output. So if you ask me why I choose only 10 data output, why it's not a 50 data output or 100 data output, we must understand that in order to make a pulse Q switch, the power must penetrate into the filler, not directly, not fully penetrated. It will penetrate just once it in the what we call in a fully saturated state. If I take the 11 data, it will the frequency of the pulse lasers will be distorted, and this will make the power to be fully penetrated, and the the film cannot be used, and I have to replace it with a new one. So I call it as a threshold value because the 11th data is not counted because it will go to its threshold value. So in the oscilloscope, you can see there are three parameters that are shown in the oscilloscope. The first one is a frequency, stand for the repetition rate in terms of kilohertz. The second one is the pulse period in terms of microseconds, and also the pulse width in terms of microseconds. What is a pulse period? A pulse period means that one pulse period of the pulse lasers to be on and off for complete one and off for one cycle, it is called a pulse period. That means from this point to another point, it's called as a pulse period. So what is pulse width? Pulse width is the width of this pulse period. It is merely half of the value of the pulse period, and there are relationship between all these parameters, and I will show to you after this. So this is the output, all the output that have been all the data that have been obtained through the research that have been conducted in one semester. So the input as you can see, the interval of the input current is in 0.01 m or 10 milliamp. So I want to see the relationship between all the parameter, which is the repetition rate, the pulse width, and the pulse period, to each other whenever the input current is increased. So to analyze it, I have to make a graph of the pump power, the input pump power. So I need to convert the input current into input power by using the formula. So after I have changed the ampere to the milliwatt, this is the value of the power. Okay. So from the data, I can make two kind of graph, which is to show the close relationship between all the parameters. The first graph shows the relationship between output power and pulse energy versus the input power. So as you can see, whenever the input power is increased, the value of the output power is also increased. This is true based on the previous research from by using the different what we call the different SA film. It also shows the same result as this one, as the graph one. Okay, so from here we can say that whenever the pump power is increased, the output power is also increased. So both of it is in directly proportional. Okay, so for graph 2, we can see this is a graph of repetition rate in terms of kilohertz and the pulse width in terms of microsecond versus the input power. So whenever the input power is increased, the repetition rate, the blue dot, also will be increased. Because of what? Whenever the input power is increased, the frequency will be increased to achieve its threshold value until it can fully penetrate the film. And this is not what this research is have been conducted. So to prevent it, I have to stop it at the 10 number of data. So whenever the repetition rate is increased, the pulse width obviously will be decreased, because when the repetition rate is increased, the pulse lasers will be extract to be smaller. When a single pulse period is small, the pulse width will also be small. Okay, so this is overall process of the journey of process, the research process. So this is how I check the fiber ferrule surface, and this is the method how to splice the optic fiber cable. Okay, this is my cost structure. For overall, the total is 178 ringgit, and the machine, all of the machine and the components in the cavity have been sponsored by UTEM. Okay, and the application of this research is mostly in the medical section and telecommunication section. So okay, and that's all from me. Thank you.